Hello viewers, in today's class we are going to discuss one important problem from definite integrals, and here we have this integral that is 0 to pi by 4 and square root of 1 plus cosine 4x dx, right? So here we have written that we have to solve an integral involving the modulus function, right? So here we do not see the modulus function, right? But when we simplify this integral, then in the later stages we will see that this integral or this integrand reduces to the modulus function, right? So let us start. Now, in order to solve this definite integral, let us apply some trigonometry here, right? So let us first see the formula for cos of 2 theta, right? So we know that cos 2 theta is equal to 2 cos square theta minus 1, right? Now see, here we have 4x, right? So let us consider this integral as I, right? Now here let us replace theta by 2x. So what we will get here, will get cos of 4x, because theta is 2x, so 2 times 2x is 4x, and here we have 2 cos square 2x minus 1, right? Now we can take this negative 1 to this side, so we have 1 plus cos 4x is equal to 2 cos square 2x, right? Okay, so now we have obtained this identity. Now let us replace 1 plus cosine 4x by 2 cos square 2x. So what we will get? We'll get 0 to pi by 4, and here we have a square root of 2 times cos square 2x and dx, right? Now let us take square root of 2 outside the integral sign, because it is a constant, so we have 0 to pi by 4, and here we have a square root of cos square 2x dx, right? Now here comes the role of mod function, right? So now we know the definition of mod function, that is say mod of y is equal to square root of y square, right? Okay, so now here we have cos square 2x, right? So we can now write mod of cos 2x as equal to square root of cos square 2x, right? So here we have replaced y by cos of 2x, right? So here we are going step by step, right? So here we have square root of 2, 0 to pi by 4, and now square root of cos square 2x can be written as mod of cos of 2x, right? Okay, so now here we have to apply again some concepts from trigonometry, right? Now let us first concentrate on the limits. So here limits vary from x is equal to 0 to x is equal to pi by 4, right? So it implies that x belongs to 0 to pi by 4, right? And here we have the angle 2x, right? So we have cos of 2x. So if we take the interval for 2x, then 2x belongs to 0 to pi by 2, right? So we have multiplied 0 and pi by 4 by 2, right? So what does it imply? It implies that when x belongs to 0 to pi by 4, then 2x, that is twice of x, belongs to the interval 0 to pi by 2. And here we have cos of 2x, right? Now from the sign convention in trigonometry, we have here 0, here we have pi by 2, here we have pi, here we have 3 pi by 2, and then we have 2 pi, right? So this is the first quadrant, this is the second one, this is the third one, and this is the fourth one, right? So now 2x, this angle belongs to 0 to pi by 4. It means we have to restrict ourselves to the first quadrant, because 2x belongs to 0 to pi by 2, and in the first quadrant we know that all the trigonometric functions, that is all the six trigonometric functions, are positive in the first quadrant, right? So now mod of cos 2x can be written as simply positive cos 2x, right? So this is by virtue of the definition of mod function, right? Because see, mod function says that mod of y is equal to positive y whenever this y is greater than or equal to 0, and mod of y is negative of y whenever y is less than 0, right? So here in our in this case, mod of cos 2x must be positive cos 2x, because 2x belongs to the interval 0 to pi by 2, which is the first quadrant, and in the first quadrant all the trigonometric functions are positive, right? So now we can write square root of 2, and here we have 0 to pi by 4. We can safely remove the mod sign here, and we can write plus cos 2x dx, right? So now this is a simple integral, and the integral of cosine 2x is half sine of 2x, right? And the limits are from 0 to pi by 4, right? So now we can take this half outside, so we have root 2 over 2, and when we take x is equal to pi by 4 here, we get sine 2 pi by 4, that is pi by 2. And when we take x is equal to 0 here, then 2 times 0 is 0, so we have sine of 0, right? So now here we have square root of 2 over 2, and sine pi by 2 is 1 minus 0, so we have root 2 over 2, right? So now if we rationalize this expression, then we'll get root 2 over 2 times square root 2 over 2. So we can now have I is equal to root 2 times root 2 is 2 over 2 root 2. So 2 and 2 get cancelled. So we are left with 1 over square root of 2, right? So the value of this integral is 1 over square root of 2, right? So viewers, this is how, by making use of different concepts from trigonometry and the theory of functions, we can solve these type of integrals.